Hello all. Today I'm speaking with Mr. Harshavardhana Gourineni, Executive Director at Amara Raja Energy and Mobility. And in this interaction, we will discuss the current scale and growth plans for Amara Raja's lead-acid battery business. Additionally, we'll talk about the company's focus on modernization and sustainability in its business operations. Hi, Harsha. So thank you so much for taking time today. Welcome to EVreporter podcast.
Good morning, Priyakshi, and thank you for having me here on EVreporter.
Thank you so much. Harsha, we know Amara Raja is one of the country's largest energy storage solution providers. To begin with, can you help us understand the current scale of your lead-acid battery business for both automotive and industrial applications?
Sure. To start with, I think I'll just go into a little bit of history, Priyakshi, if that's okay. We started as an industrial battery player back in the mid-'80s, entering into telecom with the first maintenance-free valve-regulated lead-acid battery that really, changed the game in telecom that day with longer cycle life and better operating under the Indian conditions of that time, where power disruptions were quite frequent. And from that, we slowly entered new segments and got into automotive in early 2000, again with the maintenance-free battery, which really changed the game once again. We've grown quite, scaled in both the industrial and automotive side over these decades. So now we've, last year crossed about 10,000 crores in revenue with a good mix between automotive and industrial. And we enjoy a very good share of exports as well within that. We're roughly about 70% automotive, and within that 70%, 1/3 of that would be exports now. And being the second, arguably the largest player in some categories, second largest in terms of revenue in India, we're automatically qualified as a scaled player within the global ecosystem.
Correct.
That kind of speaks to our scale at the moment. Of course, we've also entered new energy quite recently within the last 2 years in a significant way, and that's starting to also add in terms of revenue.
Right, of course. So you said 10,000 crores is the current revenue. So in terms of scaling business, specifically your lead-acid battery business, what are your plans? What numbers do you see yourself touching in the next 2 to 3 years?
Next 2 to 3 years, I think we've been enjoying a healthy, high single-digit CAGR in the lead-acid business. Actually, if we look at Q3 over Q3 last year to this year, we actually grew at 12%, and this is at a time when many people are anticipating headwinds. So I think it goes to say that there's a huge scope for lead-acid batteries in the emerging scenario with a lot of electrification of transport for overall decarbonization. All these efforts are happening, but lead-acid is part of that solution. And maybe if I can just elaborate a bit, there's the residual part which we'll leave aside for now, which will continue to require these starter batteries. Up and coming platforms, a lot of hybridization is happening because the goal is to, of course, reduce our emissions. How we accomplish that, there's different solutions in the near term, midterm, and long term. And long term, of course, we're looking more at a total BEV scenario. Hydrogen has been proven as feasible technically, but not commercially. So I think that the jury's still out on that. But in this, if we give it a 20-year runway, lead-acid batteries will continue the SLI application in existing vehicles, actually upgrading themselves quite a bit. New technologies such as AGM are coming into the market to serve the start-stop application, to support with the ever-increasing electrical loads on the system. And then within hybridization, there's a lead-acid battery as well, along with a usually an alternate chemistry high voltage system, usually a 48-volt system, coming in a range of lithium and nickel metal hydrate right now. Of course, we know the EV story. There's different lithium chemistries competing now, depending on what the performance requirement is, LFP and NMC. But there's an often overlooked auxiliary battery within an EV that is a separate energy system to power the critical safety and auxiliary functions. These include windows, power steering, And in some luxury cars, you see features like automatically tightening seat belts. So all these are running off an auxiliary power, which is played by lead acid battery now.
Right.
That technology could evolve over time, but seeing that platforms are developed well in advance and these indications come to the market, we know that lead acid will play an integral role in their portfolio, and there's innovations available within the space.
All right. Understood. Yeah, you talked about telecom, and of course, you have been the largest player in the telecom sector. But telecom, again, itself, with some 5G rollouts are happening on lithium now. And same goes for data centers, I think, as well. So, with all of these alternate technologies, can you help us understand what kind of advancements and innovations within lead acid are you exploring at the moment to maybe get yourselves into new markets or improve or compete with the alternative technologies?
Yeah. So if we look at industrial, telecom is one segment. Then we have data center and UPS. There are similar products as a segment. Then we have a long tail with energy storage coming up in a big way, of course. In telecom, we are seeing a big migration to lithium for as part of the 5G rollout. Smaller cell sites are requiring a different form factor. There is a better total cost of ownership with lithium. So we're also powering this transition ourselves by supplying packs into the telecom sector. Lead acid has a much bigger scope when it comes to industrial UPS because there's no form factor constraint, and usually if you break up the UPS segment to data center and industrial UPS, data center has shorter backup times, and lithium is a beneficial technology there. For industrial UPS, we sometimes see longer backup times required with depending on the location, the power requirement of the industrial unit. So lead acid is good at this longer discharge, where the opportunity to charge also is given at fairly frequent intervals. So lead acid is continuing there. We're also innovating on the ability of the battery to dynamically accept a charge, operate under a partial state of charge, and these are really the characteristics we need in the evolving power scenario where disruptions are not as frequent and backup times need not be as long.
You talked about that the EVs will also need auxiliary batteries. But that is, I think, true for four-wheelers and heavier vehicles. But from what I understand, electric two-wheelers and three-wheelers do not use an auxiliary lead-acid battery. Is that correct?
Yeah, electric two-wheelers we're seeing are not equipped with an auxiliary battery. So we're seeing some. It's usually coming down to the manufacturers who are pure play EV, like Ola and some of the Aether and some of the other players in that space. They're not having an auxiliary requirement. We are seeing some two-wheelers coming from some of the traditional two-wheeler manufacturers with auxiliary. But I think we see that maybe for that size of system and the safety requirements required, auxiliary is not so much required. And it's feasible to just step down the voltage from the main battery, because we don't have the risks associated with the four-wheeler of when the main battery needs to be shut down. If something can't power the steering and the windows and the doors and the locks, that's a problem. But of course, that's not relevant for two-wheelers. So I think without the auxiliary application, we see that going. And generally speaking of electrification also, we see that happening much quicker with two-wheeler and three-wheeler. But not all of that in two-wheeler has been at the expense of the existing platforms. I think we're seeing quite a significant growth, of course, within the EV two-wheeler space, but even in the ICE space. I think over time, we'll start seeing that leveling out and EV will take more of a share. But I think we're favorably placed where a tailwind in one direction is a headwind for us in another direction.
Yes, of course, because you're already supplying lithium-ion batteries for two-wheelers and three-wheelers, the battery packs, correct?
Yeah.
With respect, you are also working towards making your battery operations, lead acid battery operations in particular, more sustainable and circular. So
Yes.
can you throw some light on those efforts?
So we're benefited by the fact that the lead acid battery globally is probably the most successful implementation of a circular economy.
Mhm,
Every lead acid battery can be recycled, and 99% of the resources can be turned into raw material. So it's
mhm,
truly circular, and this is aided by the fact that lead recycling is quite feasible. There's two parts to that, though. In India, we see that organized players are able to easily recycle product if they're able to collect it. But we have this entire kind of parallel economy,
yeah.
unorganized sector that's also able to collect this scrap and then recycle it through um, spurious, not very environmentally sound methods, if I can
Mhm,
use that terminology. So luckily, there's policy now enabling us to secure the same scrap and put it back into our products. And regulation is forcing some of these secondary smelters to close down.
mhm,
Now, globally and within India now, every battery is turned back into raw material. So most of our raw material also is uh, is coming from recycled sources. About 80% of our batteries come from recycled sources, whether it's the lead or the plastic or the acid itself. So this
mhm.
allows us to continue, staying relevant in terms of sustainability, in terms of making sure there's a future for the business beyond, of course, technological implications. And we are actually coming up with our very own recycling unit in Cheyar, Tamil Nadu, which should be coming up in different phases over the next financial year. And that has a capacity of about 150,000 tons, catering to about 40% of our requirement.
Mhm.
And for the balance, we'll continue to leverage our relationships with existing recycling partners.
Okay, understood. And when are you expecting to commence operations at this recycling plant?
The first phase, which is lead refining, will come up during the next financial year,
Mhm.
towards the end of the first quarter. And then the second phase, probably later at the tail end of the financial year.
Okay. And but you're already procuring recycled lead for your regular battery production from
That's
other
correct.
sources. Okay.
Recycled lead and also recycled plastic. They come through the same channel.
All right. Got it. Okay. So in terms of exports, if you can elaborate, lead acid battery exports, you said it already makes a considerable part of your overall revenue. But
Right.
in terms of export, can you help us understand within lead acid batteries, what kind of batteries are seeing more demand for export, and where all are you planning to expand in the times to come?
Sure. So our exports are largely dominated by automotive batteries,
Mhm.
but even for industrial, we've been largely focused around the Indian Ocean Rim for the last few decades. So Indian Ocean Rim would be Southeast Asia,
Mm.
um, other SAARC countries, Middle East, and Africa, and we've built significant market shares in many markets. I think if I could just list a few, we're market leaders in the automotive aftermarket in Singapore, Malaysia, Cambodia, UAE, and a few other of the GCC countries. And
Mhm.
in Africa also, we've made inroads in the premium segment across countries. When it comes to industrial, we've largely served telecom markets and UPS markets, which are largely based out of Africa and the Middle East, because their power situations are also a little bit more comparable to ours, and made inroads into Southeast Asia as well. But going forward, we see various technology shifts happening on the industrial side, similar to India. In telecom, more into lithium, data center, more into lithium. The UPS sector is still with lead acid. So we'll continue to maintain that mix abroad as well.
Mhm.
In automotive, we're penetrating new markets. Um, we've just entered North America, supplying batteries that of a later technology, both EFP and AGM, which doesn't have a high demand within India at the moment. So it gives us an opportunity to, take the product to market before the Indian market is matured for it, and
Mhm.
allows us to compete at a place that's probably the most competitive market in the world and realize a better value for it. It allows us to, diversify our exposure and get a lot of cross learnings so that we can bring that back to India when the time is right.
Okay.
And if I can just add one more point on globalization, I think building these channels, building our brand, getting these customer relationships together really helps us push into the future also, because in all these applications there'll always be a battery requirement, whether
Yeah.
it's in the car for a low voltage requirement, or telecom and UPS data center. So regardless of what the technology is in the future, having our brand established, channel relationships and customer relationships intact will be really important to sustain the business and be technologically agnostic going forward.
Mm-hmm. Okay. Yeah, no, that makes perfect sense. I also wanted to ask you about so there are two key costs when it comes to a lead acid battery manufacturing. Of course, the lead and the energy that it takes to manufacture. So you've already addressed lead, that you're already procuring a decent amount of recycled lead. So in terms of energy usage also, if you can help us understand how much of it comes from renewable sources, and what are your efforts towards cleaning the operations from the energy usage point of view?
Sure. That's a very good point, very apt for the time. I think we've always been a little bit ahead of the curve in terms of recycled energy usage. We have some capabilities within the group to be setting up certain capacities. So we have rooftop solar set up on most of our plants and our own ground-mounted system, which
Mm-hmm.
is allowing us to consume about 30% of our energy needs from recycled sources. We're also we're exploring different relationships with renewable energy providers to take this to a much more significant level. This is, of course, at a time when we're rapidly expanding our, capacities and utilizations.
Yeah.
But our specific energy consumption has come down significantly year over year, and even our absolute energy consumption has come down. So on a higher volume and a higher production, we've been able to bring down our energy utilization. So that has been through certain industrial engineering efforts and also shop floor redesigns and just more efficiency brought into the process. I think that's where we have to start. We have to start with reduction of energy consumption, and then whatever energy we have to consume, we need to get as much as we can through renewable sources. So it's an ongoing effort, and we have a 2050 net zero commitment.
So I read that you and Amara Raja, you're continuously working towards modernization and digital transformation of your business. So can you elaborate on what those efforts are?
Sure. I think these are good blanket statements that are used: digital transformation, modernization.
Yeah.
I think what's really important for us is we built this core business in automotive and industrial off this lead acid technology, and we have a fixed runway. How long that runway is definitely debatable. We need not do that here, but we want to make sure that we sweat our assets and really maximize the value that we get out of this core business.
Mm-hmm.
And in many ways, digital implements, whether it's on the shop floor to I think mechanical automation is something we've been doing for a while, but automation of certain decision making and logical processes has allowed us to really bring out more capacity in otherwise fixed footprints,
Mm-hmm.
and also bring down operating costs. For example, looking into predictive maintenance instead of preventative maintenance, where we're, as just an example, use certain sensors to first get trained on different failure modes, and then the sensors will then start giving that information to you through an algorithm that is able to recognize these patterns and tell you before an equipment breaks down, so you can maintain it in a certain way. So that allows you to not only have an increased uptime, but usually during this period of time before a breakdown, the equipment's ability to perform efficiently also comes down, increasing your operating expenses.
Mm-hmm.
So this is one such implement that really helps us boost productivity and reduce our manufacturing costs. And there's a plethora of other things. And when it comes to we're looking at we've rolled out a CRM for addressing our field force and service related issues, which allows us to get a lot more productivity out of an existing headcount
Mhm.
and allows us to give a better quality of service to customers. And we have multiple stakeholders when it comes to customer engagement. We have our channel partners, we have retailers, mechanics, and of course the end consumer. So this allows us to not split our focus, but to adequately address everyone down the chain through using what was a software platform to start with, which has many AI implementations within itself now.
Mhm. Okay.
Now, when we have the ability to be digital, we have the ability to also cross deploy a lot of these implements across plants and across functions. So we're starting from using analytics at the financial reporting level to make sure that we're having the right mix of products. Products are available throughout the supply chain. We have a vendor portal we've rolled out recently that allows us to have a full visibility on the performance of vendors and allows them to also be competitive in a reverse auction kind of process, making sure that accountability is had throughout the value chain.
Mhm.
So, I mean, the list can get pretty long, but this helps us to uh, use platforms to address some of our value chain concerns. And these platforms are usually cloud enabled, so updates are usually rolled out quite seamlessly. It allows us to, have a central headcount that can stay quite relevant for a longer period of time, and without needing upgrading in terms of more resources across a greater span. Some capability upgrades are something we do internally. So it's really helped us scale and achieve a double-digit growth in an otherwise, if you look at the growth of automotive sector itself in India, has reduced to high single digits.
Mhm. Yeah, understood. Okay, I think for the last question, I will just have some final comments from you on how do you basically envision the coexistence of different technologies, because it's not going to be a one technology play. There will always be a mix. Different applications are more suited for different kind of technologies. So how do you envision the coexistence of these different technologies in automotive and industrial sector, and what role do you foresee for lead acid batteries particularly amid this transition?
Oh, sure. If I can start just with the automotive space, I think the goal is, of course, to reduce our environmental footprint.
Hmm.
And electric vehicles are a potential solution, but they don't fix the entire value chain. We so of course have to work on how power is generated in the country and the world. It's largely still from fossil fuels, so we have to move to renewable sources there, get a larger mix of nuclear maybe, and
Mhm.
really find a way to make sure that from generation to consumption, things get more green. And in that process, I think aside from generation, there's a lot of work being done, especially on the EV side, to lightweight vehicles, to find more efficient designs on all components. And a
Mhm.
lot of this um, has the potential to cross-pollinate back into ICE platforms also, especially when we're looking at hybridization. If the different components allow for the vehicle to get much better, fuel mileage, also allowing for basically a reduced cost of ownership also. I think we'll see a long runway where EVs will be coming in a much bigger way, and a lot of the existing fleet will also move to hybrids.
Mhm.
Hybrids with maybe flexi fuel, more ethanol blending. There is definitely scope for hydrogen to come in a big way as soon as commercial viability is there. So I think I don't see a market where ICE is fully gone, just
Yeah.
drastically transformed into a more, sustainable, more environmentally significant way. And of course, EVs growing in the park, and lead acid will have its share in all of this because they also won't be products that will be capped off in technology, because the same way that automotive components and fuel is being um, studied and R&D is going into them in such a big way. There's characteristics of lead acid battery that are also benefiting from the entire, buzz and bullishness around energy storage now, where the same R&D methods can be used to analyze the different failure modes of a lead acid battery to help bring the cycle life up, to increase the dynamic charge acceptance, to reduce the footprint, to work beyond 12 volts. There are bipolar batteries which actually allow the lead acid battery to scale beyond the 12 volts to 48 volts and beyond. It's still initially being proven out at a commercial level throughout the world. So not so much to report there, but it's definitely technologically feasible. So it's just an implement that shows that this technology can be applied to the ever-changing technological requirements of the vehicle. So I think when there's so much efforts being put into, improving R&D within the country and the world, I think everything will benefit. And a cross-pollination of ideas will definitely help us all moving forward in decarbonization of transport. If we go to the stationary storage side, whether it's telecom or UPS, I think we're seeing lithium taking a large share, especially with the 5G requirement of small cell sites, and of course a rapid rollout of so many of them. The data center requirement, which benefits from having again a low footprint, infrequent power outages, low backup requirements, but high discharge during that time. Lithium is proving out to be very good in that space. But when we look at longer duration energy storage, especially at the maybe grid level for storing renewables, right now, neither lead or lithium are proving to be the most efficient means of energy storage there. Because ultimately, for renewables to really take off in a big way, I mean, you'll be aware that solar is cheaper than grid scale now, but not the cost of solar with energy storage. So that needs to come into a way where both cost-wise and further impact-wise, that it becomes more suitable. Then I think the grid can really transform. I think there's different technologies that are vying for a place of relevance there. Certain technologies like zinc air, like different types of redox formations. These are all being tried in pockets, and nothing's been expanded into a large scale grid level facility. So I think these need to be proven out. A lot of them have better performance characteristics in one direction, but don't cover all, and also have better characteristics in terms of their ability to be recycled. Lithium right now doesn't have the same ability to be be made circular compared to lead acid and some of the other chemistries out there. So I think all of these prove wonderful test cases for many of the brightest minds to start working on and continue working on. But the jury's still out. I think we have the opportunity in energy storage, especially where form factor is not the main requirement, the main constraint at least. So you get to work with multiple technologies and continue working because switching costs aren't so high. In many cases, new technologies can be dropped into existing requirements and function quite well. So energy storage, I think, is a huge opportunity and a very well understood requirement. And I think different technologies will be competing there.
Okay, very well said, Harsha. And thank you so much for your time. It's been a pleasure speaking with you.
Thank you, Priyakshi. Thank you for having me today, and it was wonderful.